Have you ever stopped to think about how different the lights in your home are now compared to just a decade ago? I mean, even the lights on your phone or in your car. We've gone from a world of hot, glowing wires to these cool, tiny, and super efficient little electronic chips. So today, we're going to pull back the curtain and look at the amazing science that made this whole lighting revolution happen.
Okay, let's just jump right in with the big question, right? Why could you literally burn your hand on an old light bulb, but a new LED bulb stays cool to the touch, even when it's just as bright? The answer isn't just a simple tweak in design. It's a total rewrite of the physics of how we make light.
And really, it all boils down to this one massive difference. The old way, incandescence, that's just brute force. You make light by getting something crazy hot. But the new way, with LEDs, is so much more elegant. It's about coaxing electrons inside a special material to release light directly. It's heat versus electrons.
So to really appreciate just how genius the LED is, we first have to understand what it replaced, the classic incandescent bulb. Let's take a look at this tale of two lights, and we'll start with the old-school heat-powered method.
You know, the process here is actually pretty simple. Think of it like a toaster. You force electricity through a really thin wire. In this case, it's a tungsten filament. Now, that filament resists the electricity, and that resistance creates an insane amount of heat. We're talking over 2,500 degrees Celsius. It gets so hot that it literally glows white hot, and that's the light you see.
But here's where you see the huge problem with that old method. Just look at this breakdown. A staggering 95% of the electricity you feed into an incandescent bulb is completely wasted as heat. Only a tiny little 5% actually turns into the light you want. It's basically a space heater that just happens to glow a bit. So inefficient.
Okay, so now for the main event. This is the quantum leap. We are leaving the world of hot metal behind, and we are going to take a journey deep inside that little semiconductor chip that's at the heart of every single LED. This is where the real magic happens. The entire idea behind LED technology can be summed up in this one word: electroluminescence. Yeah, it's a bit of a mouthful, but the concept behind it is just brilliant. It means you can turn electricity directly into light, completely skipping that incredibly wasteful middle step of having to create a ton of heat first. So how does this actually work at a microscopic level? Well, inside an LED chip, you've got these two special layers. Think of one layer, the N-type, as being packed full of extra electrons. And the other layer, the P-type, is the opposite. It's full of what scientists call holes, which are basically empty parking spots for electrons. So when you apply some voltage, the electrons get pushed from their crowded side over to the side with all the empty spots. And when an electron finds an empty hole at the junction, it falls in. And in that exact moment, poof, it releases its extra energy as a single particle of light, a photon. And get this is how we get different colors of light. The specific material they use for the semiconductor determines what's called its band gap. And all that really means is how much energy an electron has to give up when it falls into a hole. A big energy drop creates a high energy photon, which we see as blue light. A smaller drop makes a lower energy photon, like red or green light. It's just beautifully precise physics. But that brings up a really good question, right? If LEDs are so precise at making one specific color, how in the world do we get the plain old white light we use in our homes? Well, it turns out there's a really clever trick involved.
And the secret ingredient is this amazing stuff called phosphor. You can think of it as a light converter. It has this incredible ability to absorb light of one color, get all excited, and then release that energy as light of a totally different color.
So the recipe for white light goes like this. You start with a powerful blue LED. And by the way, that blue LED was the key to everything. Inventing it was a Nobel Prize-winning breakthrough that finally made all of this possible. You take that blue chip and you coat it with a layer of yellow phosphor. So the chip shines its blue light, but some of that light gets soaked up by the phosphor, which then starts to glow yellow. The leftover blue light that gets through mixes with this new yellow light, and our brains see that combination as clean, white light. It's such a clever bit of chemistry that unlocks the whole potential of the LED. So simple, but absolutely ingenious.
So, we've kind of geeked out on the how, which is super cool. But now, let's talk about the why. Why was this change from hot wires to cool chips such a complete revolution? Well, it all comes down to these incredible gains in efficiency. So, what does all this add up to? It's really summarized by this one incredible number: 90%. That's how much more energy efficient an LED can be compared to one of those old incandescent bulbs. That's not just an improvement,
That's a monumental leap forward.
And this chart really puts that number into perspective. To get the same amount of light, a standard old-school bulb needed 60 watts of power. An LED that's just as bright needs only about 10 watts. You're getting the exact same result for a tiny fraction of the energy.
And you know, it's not just about energy savings. This table here lays out the whole story. And the difference is just staggering. Look at the lifespan, 1,000 hours versus up to 50,000 hours. The heat waste, 95% versus just 10%. And durability, a fragile glass bulb versus a tough, solid-state device. I mean, in every single category, the LED is just the clear winner, hands down.
And that efficiency? It has a massive real-world impact. It drastically cuts down our electricity use, which means lower carbon emissions. That super long lifespan means far fewer bulbs are being thrown out and ending up in landfills. And unlike those swirly CFL bulbs that were popular for a while, LEDs have zero toxic mercury. It's a win for your wallet, and it's a huge win for the planet.
But this technology didn't just stop at replacing the light bulb in your lamp. Oh no! The core idea of electroluminescence has completely exploded, and now it's in almost every corner of our modern world.
Seriously, just think about it for a second. The screen you're probably watching this on right now, it's powered by LEDs. So are your traffic lights, your car's headlights, and all those little indicator lights on your smart devices. Their efficiency, their toughness, their tiny size, it's made them the universal light source for the digital age. They are everywhere.
And the story is not over. Not even close. The next generation is already here. You've got OLEDs, which use organic stuff to create these stunningly thin, even flexible displays. And then there's micro-LEDs, which shrink the whole technology down to the size of a single pixel for ridiculously bright and efficient screens. The same fundamental physics just keeps evolving. So, the next time you flip a light switch, I want you to remember this. For almost all of human history, our light came from heat, from fire to gas lamps to glowing hot wires. LEDs broke that ancient chain. They set light free, directly from the quantum world of electrons. You're not just turning on a lamp anymore. You are literally watching a masterpiece of quantum physics light up your entire world.